and welcome to another GCSE Computer Science video with me, Mr Goff, for MrGoff.com. This video will focus on defensive design. Defensive design is writing programs to try to avoid potential problems from accidental or deliberate misuse. Some of the things we're going to look at in more detail include handling inputs, sanitization, validation, authentication, and maintainability. A program should be designed so that a user entering an unexpected data type, such as a word where an integer is required, would not crash the program. In Python, this can be achieved with the try-except statement. Authentication refers to having a system of username and passwords to confirm the identity of the user of a program. This also allows different access rights so users can do different things within a program. Any authentication system should be resistant to brute force attacks and to hacking. Sanitization is the removal of unwanted characters from input data. When we have an input form that's attached to a database, one way we can protect against SQL injection is to sanitize our inputs to try and remove anything that looks like SQL. Validation is making sure that input data is likely to be valid. There are a number of types of validation. A presence check, where we check that some data has been entered into a field. A length check, where we check that the data entered fits between either a upper or lower bound of how many characters it can have. A range check, where we make sure that a number that's entered is within a certain range, such as a number between 1 and 5. A format check, where we can check that the data entered is in a certain format, such as the format of a postcode or a registration plate for a car. And list, where only the data in a pre-approved list is accepted. Most programs are large and worked on by more than one programmer. They also may well be maintained by different people to the people that wrote them. So there are a number of things that should be done in order to make the process of maintainability much more simple. Using subprograms improves maintainability because it means the program will be easier to understand and changes will only need to be made to individual subprograms. As well as basics like no spaces in names, starting with a letter or underscore, and using meaningful names, programmers often use naming conventions. Constants are generally written in all capitals. For regular variables, either snake case or camel case is usually used. Snake case has all letters in lowercase, and where more than one word is used, an underscore is used to link them. Camel case starts with lowercase, and each new subsequent word in a variable name has a capital letter to start it. If you are learning in Python, indentation is part of the syntax, but this is not so in all languages. However, in all languages, it is good practice to use indentation and spacing to make your code more readable. Things like leaving a line's gap between a subroutine and the next line of code can really help improve readability. Commenting means leaving notes in your code to explain how it works. It is increasingly important in large programs where the person who writes the code may not be the one to maintain it. There is an old saying in programming that's been attributed to many different people. Always code as though the person who maintains your code will be a homicidal axe-wielding sociopath that knows where you live. So maybe tidying up the appearance of the code and adding a few comments is not such a bad idea. That brings us to the end of this video on defensive design. Join me in the next video when I'll be taking a look at testing. Use the resources at MrGoff.com to help you revise computer science. And until next time, it's bye for now.